Good evening. So, guys, in the last section, we have discussed about like whatever the states of the OSPF we have. So we have seen like we have a down state, attempt state, init state, two-way, start, exchange, loading, and flow, right? And then after that, we have seen how many types of the packets we have. So basically, we have a 5 types of packets. So we have a hello packet. Okay, 1 minute. So we have seen that we have a hello packet, then we have a DVD packet, then we have a LSR link state request, in link state update, and the link state acknowledge. So this packet is used to form the neighborship, and this packet, DVD packet, then we have a LSR request, LSU, right? This packet is going to form the adjacency. Okay, so and this is the acknowledge packet that is going to represent that whenever your router will send the LSU packet, then router 2 will give the acknowledge of that one. That's the meaning of LS acknowledge. That's just going to represent that it's a reliable packet or reliable protocol. Okay, so now, so in the first day that we have seen at how to configure the OS. So this is the basic command router OSPF1. As we put the router OSPF1 process ID, a 16-bit of number. What happened? The router is going to create the LSDB table, right? And when the router OSPF number 2 on this guy, it will also create the LSDB table. Once this router 1 is going to 2, router 1 is going to form the neighborship with the router number 2, right? Once both the router is going to form the neighborship with the router, what happened? R1 is going to share the own information, right? R1 is going to share the own information about this interface, right? R1 is going to share the own information about this interface, and that information is known as a LSA, right? LSA stands for link state advertisement. So LSA is what? It's the information about this link, right? It's the information of this IP address. This is the information of when R1 is going to share this information to the R2, and R2 is going to share this information to the R1. This is known as a LSA, information about link, right? And this LSA will be stored in the database table. So R2 will send the own LSA to the R1. So it will store this information in the 12 in the R1 database table, and R1 is going to share this information to the R2. R2 will store this information in the database table. And from the database table, they will push this information into the routing table. From the database table, it will push this information to the routing table. This is how the OSPF works. But this LSA, guys, this LSA has been categorized based on the area. This LSA has categorized based on the area. So basically, we have a multiple types of LSA. The first LSA we have is known as a router LSA. LSA has categorized based on the area. So right now we have a single area configuration. We have area 0, and we can say the single area configuration, right? So the first LSA of the router OSPF is the router LSA. As the name suggests that router means what? Every router, right? Every router in your network is going to generate this LSA. This LSA. So right now, how many routers are present in this area? There's a 2 routers are present in this area, or we can say in this broadcast domain, right? There's 2 routers present in this area. So what happened is you will have a 2 router list over there. Every router in your network will generate the router list, and that contains the information about how many links are connected to me. How many links are connected to me? What's the meaning of that? For example, first of all, R1 is going to send the own router list to the R2, and R2 is going to send the own router list to the R1, right? Suppose, just take example right now, what happened? R1 is going to inform that I have a one link connected, that is 12.1. R2 is going to inform to the R1, hey dude, I have a one link connected, that is 12.2. Not only this information, they will have a lots of information. I'm just giving you a brief information of that. They will have a lots of information in the router, let's say. But main information is they are just going to tell you how many links are connected to me. And every router in your network is going to generate the router, let's say. For example, in future, if you have a one more route over there, then R1 is going to inform to the R2, this is the loopback. R1 is going to inform to the R2, I have a two links connected. One is the 12.1 and another is a loopback. That is my stop network. And this is my transit network. For example, R2 also has some links connected with the behind the R2. So 2.0.0.0. R1, R2 again send this information to the R2. Hey, I have another link that is a 2.0.0.0.0 that has connected with the stop network. That's my loopback. So R1 is going to share the own link information to the R2. That's a two link information. And R2 is going to share the own link information to the R2. Two link information. One is a transit, another is a stop. In future, again, what happen if the another link will be added? R1 is going to share the another information to the R2. Hey, I have another link that is the again stop network. That's my loopback. If R1, just take if R2 has a connectivity with the R3, right? This is 23.2. So what R2 is going to do? R2 is again going to inform to the R1, hey R1, I have another link connected that's a 23.0, right? That's a connectivity with the transit network. Why I'm saying that? Because this is the transit network, right? This is the transit interface. Loopback is a stop network. So basically what happened in your router, let's say, the router is just going to share the information about how many links are connected to me. And all this information will be stored in the LSDB table, all this information. So LSDB stands for Link State Database Information Database that is going to contain the collection of LSA. Same thing, R1 is also going to contain the same information, LSA information, the LSDB table. So at the end of the day, what you understand from this thing, at the end of the day, what happened, each router is going to share the own link information and R2 is going to share the own link information to the R1. Guys, give me 1 minute. Actually, my eye is burning actually. So I'm not able to see that laptop. Okay. So let me show you the practical, then it will become a very clear to all of you. This is the first LSA. So every time just have the look up the name of the LSA, right? The router LSA is the first LSA of the OSPF. And it is also known as a type 1 LSA, right? Sometime what happened in the interview, they will ask you what is a type 1 LSA. Type 1 LSA is the router LSA. And each router is going to generate a one router LSA. Sometimes what happens, the people will get confused. He said that okay, I have a 5 links connected, it means that 5 router LSA. No, router means what? Router means router, not the link. Router means one router, doesn't matter how many links they have. If they have 100 links behind this guy, R2 is going to generate the single router LSA to the R1. In your network, right? In this my broadcast domain, 12.0 broadcast domain, how many router LSA we have? Only R1 and R2. 2 router LSA. Is it? Now, see this topology. Can tell me anyone how many router LSA will be there in this area, in this domain, till this point?
6.
Perfect, right? We have a 6 router LSA. One is this guy R1, one is the R2, one is the R3, one is the R4, one is the R5, and another is the R6. And guys, I'll tell you one thing that's a very, very important. Many times in the interview, what happened, they will give you like this scenario and they will ask the question, how many router LSA will be there? How many network LSA will be there? And what they will do, they will just configure the multiples interface over there. And now they will say that how many router LSA will be there? Tell me. How many router LSA? Of course, only 6 router LSA. Doesn't matter how many links are there, only 6 router LSA. If you have a 6 router LSA, 5 router LSA, 4 router LSA. Router means what? Router LSA. Let me configure this point till this area, this box. Okay, I think so. My putty is size of that. मुझे लगता है 8 वाला बैच कैंसिल करना पड़ेगा.
Excuse me, sir.
बोलो भाई.
Sir, that you had that example you showed, no, sir, 6 router LSS.
हाँ.
Now suppose R1 will send its router LSA to each and every other router, sir. In the
Right.
Okay, sir. Thank you.
So I believe so. Perfect, right? Yeah. Chalo. So you can draw this topology. Either you can do one thing, just take a snap in your phone, right? Because it's not possible to show you the topology every time, right? So just take a snap of this guy. Okay. So right now, let me configure this IP address first of all. I think so. I don't have the IP address. Any config terminal into show IP interface brief. Interface 0/0. /24. What is the election criteria of master slave?
The one which has higher router ID.
Yeah.
Will be elected as master and other as slave, sir.
And what happens if I'm going to configure the the priority of interface is 255?
DR can also become slave, sir. No need, not compulsory to become master.
What? Now, what happens if I'm going to configure the route interface priority as a 255?
That will become DR, sir.
Sorry?
DR it will become highest priority.
Always it will become the DR. So if the condition is something like that, if there's someone is say that my condition is always, so you will get this kind of condition in the exam as well. As what happened, they will ask you to always R1 should become the DR. Always, doesn't matter. Whenever this router will wake up, always the R1 will become the DR. So in that case, what happened, you just need to configure the priority of this interface, because DR is the properties of interface, and one broadcast domain has a one DR and one BDR. Rest of the router will become the DRO and BDR. Sorry, DR and BDR. क्या बोल गया मैं? DR, BDR, and rest of the router DRO. So let me configure the IP OSPF 1 area 0. So you can configure the area in the two format. Either you can use the dotted decimal format or decimal format. Area is a 32-bit number. You can use any one. Area 0 is reserved for the backbone. area 0 should be present in your network if you want to provide the inter-area communication. Between the two area communication, you must have a area 0. So if you see do show IP interface, waiting state is going on, right? So right now what happened, there's no DR and BDR. Guys, tell me what is the meaning of DR 0.0.0?
Still, it has not been selected.
Okay. Okay, perfect. What is the meaning of this question? R1, R2. So R1 has a link to LR1, R2 has a link to LR2, right? This interface is saying that I'm the DR. Okay, but in the neighbor table, there's no BDR. What is the meaning of that? Batao. R2 is elected the DR, and in the name in the information there's no BDR is in there. Right now, what happened if you see show IP OSPF interface 0/0. He's a DR, right? Okay. What happened if the BDR is not there? Sorry, if the BDR written is there, but the BDR is saying that not elected. What's the meaning of that? In this condition, what happened? R1, R2, DR is elected. He's saying no BDR. It means that OSPF is not running on the R1. OSPF is not running on the R1. Chale? So right now, what happened? This R6 has become the DR because they have a higher router ID, and this guy will become the BDR, right? And the rest of the router will become the DRO. So as I told you that one network is going to represent that, sorry, one router is going to generate the own router list, right? So if you go, okay, let me do one thing. Otherwise you will get confused. Router is from one, router ID 101. Let me make it more easy. Otherwise you will get confused. Do clear IPS for process. Yes. Now you will understand in a very easy manner. So whenever, see, for example, what happened if the R1 has elected as the router ID anything, right? For example, 11.11.11, right? So once you put the route, and if you want to make R1 as a router ID 1.1.1, so what happened? You need to give the manually command router ID, right? 101. Then after that, you need to restart the process over there. Okay. Otherwise, reconfigure the OSPF again, or either restart the OSPF process. So if you go on a area router right now, so everything is cool, right? Loading full 6.6. Show IPs of neighbor. R1 should be have a 5 neighbor. Okay. And as I told you, I remember yesterday that we have discussed like whatever the router that will become the DR and BDR. Okay. Whatever the router that will become the DR and BDR, they will move in the adjacency state like a Xstart, Exchange, loading, and full, right? And whatever the DRO router, they will stuck in the two-way state. You can see that. So these are my DR and BDR. That's why it's moving in the full state. Is it? This is the priority of this interface, and this is the neighbor router ID, right? And this is the date time. This is the address that I'm forming the neighborship. This is the router ID of the router, right? This is the router ID of the router, and I'm forming the neighborship with this interface. Quick question. If someone will ask you in the interview what happened, they will just ask a simple question. How many neighborship a single interface will form? How many neighborship a single interface will form?
16.
Right now it's 5, right? Right now it's 5, but it will form the unlimited. And one more thing, that in the single area, right? In the single area, the Cisco is recommendation you can use the 50 to 60 routers over there. It's a recommendation things. You can use the 70 as well. You can use the 70 as well as, but it's a recommendation to use only 50 to 60 router, so that the load will be not increased, right? It's a recommendation. Like in the BGP that we have read, right? Like to run the BGP, we need to require the at least 5112 RAM. Okay, at least 5112 and 256 GB RAM. But still, if you see what is the RAM of this guy, configure, and if you see this memory slot 180 MB, right? 128. I can run the BGP on this guy, right? I can run the BGP on this guy. Same thing. What happened? It's a recommendation to put the 50 to 60 router in the single area, but you can put multiple one if you want. Okay. Now, if you go on R1 order, I have a 5 neighborship, and if you check the database table, how we can check the database table? So, I want to show the information about OSPF. OSPF works on the which protocol? IP. Which protocol I want to show? Because IP, EIGRP also works on the OSPF. Sorry, EIGRP also works on the IP, and OSPF also works on the IP. Then I'm gonna look up the database information. So you can remember each and every command, just link with each everything, right? Show me is what I want to show this information about what OSPF. OSPF works on the which protocol? IP. OSPF database. What is saying that? मैं स्क्रीनशॉट ले लेता हूँ. ये 1.2 कौन आ गया है? There's 1.2. It should not be there. 1 minute. It should not be there. 1.2 is a 1.2. Clear IP also process. Yes. I have only 5 versions, so I can. How can I get this information? It should be not there. 1 minute. Still is coming. Who is this guy, man? It's a wonderful. अभी तो शटडाउन में मार दिया. क्यों मार रही है इंफॉर्मेशन? एक मिनट. Who's this guy? 102. 102 R2, right? So R2 wise should have this information, man. He's not removing this information. 6.6.6.6.6 network. Oh, इसके पास IP नहीं है. Oh shit, man. That's why. चलो, अब proper आया है. Now we'll get the proper way. Perfect. So R1 is for now 6.5. So 6 is the DR BDR. Do show. Perfect. Do show accused for database. चले, ठीक है. ठीक है. So this is the R1 information. Let me show you the topology right now. Is it visible? So this is the, right now I'm present. This guy is present on R1, and what R1 is going to do? R1 is going to look up the data vegetable. Okay. So this link ID is going to represent that router ID information. Okay, in the router LSA. In router LSA, link ID is going to represent its a router ID information, and this is a 32-bit number. Then after that, advertising router means what? Advertising router is going to say that right now we are looking up the information about the router LSA. For which area? Area 0. What is my router ID? 101. What is my process ID? 101. Right now I'm present on R1. Okay. What R1 is saying that I'm getting the 6 router. Let's say one is my own information, right? And then after 2.2, 3.3, 4.4, 5.5, 6.6. So we have a 6 router. Let's say in this area, right? Sorry, in this domain. In this broadcast domain, we have a 6 router. Let's say 1, 2, 3, 4, 5, 6. So link ID means what? It is going to share the information of the router ID. Advertising router means what? Who is advertising this information? Who is advertising this information? So this information is advertised by 101. This information is advertised by 2.2.2. This information is advertised by 3.3.3. This information is advertised by 4.4.4. This information is advertised by 5.5.5. This information is advertised by 6.6.6. Advertising router. After that, I'm learning this information, right? For example, R2 learn this information router LSA about the R1, right? And put in the database table. I'm learning this information as a dynamic. So if I'm learning any information as a dynamic, we have a timer. That is the timer is known as the age in the OSPF. What is the age of meaning? Age is just going to represent that how old this LSA is. How old this LSA is. How many seconds ago, right? How many seconds ago I learned this LSA? So this always incremented by 1. Always. You can change this thing. If you want to change, you can change this thing. But by default, what happened every 1 second, this age timer will be incremented. If you have a look now. So it is 39, 223, 226, 231, 238, 242. Not for this one. Every router listens 3, 213, 233, 4, 224, 218, 239. And you see that every time this information will be incremented, right? This timer will be incremented by 1. This is just going to represent that how many second ago I learned this information. And by default, it's incremented by 1. Timer is not showing all that. Yeah, this one. This timer is going to represent that each timer. You can change this time if you want. If you can change this time, just go on the interface and say the IP OSPF transmit delay, and you can manipulate this thing. And then after that, what happened? For example, if you say that 5 seconds, then at every 5 seconds, this information will be refreshed. It's just going to tell you how old this LSA is. Then after that, we have a sequence number. Sequence number is a 32-bit number in the OSPF database table. It is just going to represent the order of LSA. Or we can see that it is also going to represent how many times your database table has modified. Remember the BGP table version? In the BGP table version, what happens sometimes whenever you will receive the update, for example, right now the BGP table is 5, right? Table version. Whenever I receive the update, I need to increment. Whenever I receive the update, I need to increment. Whenever I receive the update, I need to increment. Same thing. Whenever the modification will happen in this LSA, whenever the modification will happen in this LSA, your sequence number will be incremented by 1. Right now, what is the value is right now? 0x80000, right? It always start from this value, right? Just how much is it? 3, 2, then 4, and then 6, 7, right? Yeah, perfect. But this value is reserved, right? You cannot see this value. You never see this information. You always, this value will be started from whenever the LSA will be stored in the database table. Each LSA is going to represent by the 0x8000000001. Always, this is reserved value. And the last one, this is the starting point, and the ending point will be 0x7FFF 7FFF. This one. This was the ending point. 32-bit number. This is the range of the 32-bit number. The starting point is this guy, and ending point is this guy. But you will not see this one and this one. Always starting from this range. And this is just going to tell you how many times your database table has been modified. Second thing, this is the one condition: your database table has been modified, your sequence number incremented by 1. And after that, this is the timer of the dynamic timer, right? This is the timer, is a dynamic timer. Of course, we have some limitation of this timer. The limitation of this timer is 30 minutes. At every 30 minutes, what happened? By default, this is the behavior, right? 1800 seconds. At every 30 minutes, what happened? This database table has been refreshed. And once your database table has been refreshed, again, the sequence number will be incremented by 1. There is 2 conditions. The sequence number will be incremented. One is your database table has been modified. Modify in the sense of what? If I'm receiving some new information about this route LSA. And second thing, if your timer will get reset. In that condition, again, the sequence number will be incremented. The sequence number is just going to tell you, is this database table is stable or not? That's it. Then after that, we have a checksum. That checksum is just going to check the error connectivity. Do we have any error or not? And the last one is a link count. Link count means what? How many links are connected with the R1 router. So right now, if you see on R1, single link, right? Let's do one thing. Interface loopback number one, IP address, IP host of 180. Done. Do so IP host of database. What happened? Previously, the sequence number was what? 8002. Now, at the same time, what happened? Each will be incremented as reset, and the link count will be high. That's the meaning of whenever any things will be modified in your database table. So this the database table has been modified. I advertise the one route. At the same time, I advertise the route. The database table has been modified, and the sequence number will be incremented. At the same time, your age will be reset.
Excuse
And
me,
link count will be incremented.
sir. Can you repeat that second column, sir? AD, advertise router.
Advertised router. Who is advertising this router? This is the router LSA. Who is advertising this LSA? R1.
Okay.
See, R1. This is the router LSA that this router has created. For example, this you don't know which router is this, right? You don't know which router is this. So R1 is going to share this router LSA to the R2, R3, R4, R5, R6. How this router will know that this LSA is coming from which guy? How this router will know that which this LSA is coming from which guy? That's the meaning of advertising router. Now, if you see this information right now, let me copy this information again. As I told you that this database table has been seen on every router, right? This database table has been seen same on every router, like a mirror copy. LSDB table will be seen on every router in your area. Within the area, right? Within the area, whatever the routers are present, within the area, whatever the routers are present, they have a same information. So this is the R1 information. Let's have a look on any router. Go on R2. Is this the same information? Can you see that? Don't see the timeout because timer will be incremented at every 1 second. See this point, and this point. I'm present on R2, and this is the information about R1. Except the age, right? Because age will be incremented at every 1 second. If you see on any other router R3, they have the same information. Except the age, you can compare each and everything. That's a mirror copy, right? Mirror copy will happen on every router. Then it is going to create a map of the topology. If you go to R4, same information. Not for the R1. Even if you check for the any other LSA, right? Even if you go for the 2.2.2, 3.3.3, 4.4.4, everyone has the same information. Nothing is different. Because each area, right? Each area is going to run the separate algorithm. For example, this is the one area, this is the another area, and this is the another area, right? So in a different area, what happened? We have a different routers. Router number 1, 2, 3, 4, 5, 6, 7, 8, 9. So this router has a own algorithm. Sorry, this area has a own algorithm. This area has a own algorithm, and this area has a own algorithm. So in this case, what happened? Whatever the router that is present within the area, they have a same database table, same database table, same database table. But between the area, they have a different database table, because this algorithm number 1, this is the algorithm number 2, and this is the algorithm number 3. within the area, whatever the routers are present on that router, they are running with the same algorithm. And this is the reason why they have a same information. If you go to R5, when do show IP host for database, same information, nothing is different. Except the timer, you can check any value. So what R5 right now, R5 I'm present on R5, and R5 has the information over the R1 database stream. Again, if you go to R1 router and do some update, interface loopback number 2, IP address will be 10.10.10.10.10.10. IP host of 1 area 0, right? What happened? Your age will be reset, sequence number will be changed, checksum will be changed, and link count will be changed. This 4 value will be changed at the same time. Check on our R6 now. Do show IP host of database. Previously, this was the information. Can you see that? Every time, whenever the database table has been modified, this 4 value will be changed. Again, change. Previously, link count was 3, now 2, because I shut down this interface. Modification means what? Up, down, up, down. Let me do that. Go to R1 again. No shutdown. Wait for some time. Shutdown. No shutdown. Whenever any modification will happen, your database table will be changed. Can you see that? Link on is 3, right? Because I'm just flapping the interface. But from this point to this point. And they all have the same information, right? Let me show you the detailed information of this guy. Let me go for this link, capture this link. And let's go to R2. Let me advertise on one router, let's say. So now R2, I'm going to create a loopback, interface loopback number 1, IP address 2.2.2.2/8, and IP host of 1 area 0, right? Now let's see the capture. So R2 is my DRO router, right? R2 is my DRO router. Can you see this one diagram? R2 is my DRO router. So what DRO is going to do? It will send this information to whom? DR, right? It will send the information to DR, and DR will flood this information to the .5. If you see that information, not this one. One minute, let me pause this guy. Who is the DR? R5, R6 is the DR. See that same information there. So this was the R2 is sending this information because R2 was DRO, right? And DRO will send this information to whom? DR address. And what DR will we do? It will send this address to packet to the all OSPF router. Is it same information, right? If you see LS update packet, LS update packet. If you open this guy, router, let's say, if you open this guy, same information, nothing is different. It just changed the source, right? Is it? Guys, clear till this point? आगे बढ़े? So let's discuss the packet now. So as I told you that this is the IP protocol, the OSPF protocol number 89, and the TTL is by default one of this guy. OSPF LSA update packet, number of LSA 1. LSA type is the router LSA that I told you that every router is going to change the router LSA. This is the size of length 48. Ignore this value right now. This is not for you. Ignore this one. So LSA type is router LSA. You can see this one, but not, don't look up for this one right now. This one you can see the LSA is right. This one I'll teach you in the virtual link. So LSA type is the router LSA. This is the opcode value, right? The type 1, right? So the type 1 that's going to represent that. Then after that, who is the link state ID? R2 is advertising this LSA, right? Then after sequence number 804, checksum, length, flags. This flags is not for use right now, okay? Because this concept will comes in the virtual link part, ASBR part, or whenever I'm going to teach you the between the area communication. So this flag we are going to discuss later on. Right now, what happened? This flag is off, right? Why? Because this is the normal router that is advertising the router LSA. This is the normal router that is advertising the router LSA. For example, if this kind of scenario will happen, right? R2, R3, and R area 0 and area 1, right? And if R2 will generate a one router LSA, so in this case, what happened? R2 is a ABR router. If R2 will generate the router listener, then your flag will be on over there. So right now what happened is R2 is a normal router. That's why all flag is 0. And what this guy is going to say you, number of links, how many links are connected to with me. So R2 is informing, right? R2 is informing to the all this domain router, this guy, this guy, this guy, this guy. R2 is informing to all this router. I have a 2 links connected, and these 2 links are, one is my 2.2.2.2, that's my loopback address, and one is a 1.2, that's my interface address. So in the network type of OSPF, right? OSPF network type, we have a point to point, we have a point to multi-point, we have a broadcast, we have a non-broadcast. All this type of network contain the 2 types of network. One is a stub and one is a transit, right? Transit means what? This is the transit network from where I can forward the data plane traffic. But this is my stub network, that's my loopback network, stub. So what he's saying, the number of links is 2, one is a stub, that's my loopback, right? And what is the subnet mask of this guy? Single host. The metric of this guy is a 1, right? This metric is known as a cost. And the cost, the by default, the cost size is 16-bit. You can change this cost from 1 to 65535. And then after that, he's saying the type is, so one type is stub, another type is transit. Transit means what? I'm going to talk about the 1.6 information. Okay, this is the standby home. Oh, R6 is in, that's why he's in it. Right? Data is 1 or 2. R6 is sending the information and he's containing the information over what? 1 or 2. Because this information is about the router, let's say R2. And the metric of this guy is 10. This is my detailed information. This is going to contain the detailed information about the router LSA update packet. But if you want to see the same information in your Cisco CLI, you can also check that command. You can just put the command do show IP OSPF database and put the router LSA. If you want to see the same information, right? Same information if you want to see on the Cisco CLI, you can check the show IP OSPF database. I'm looking for the router LSA. OSPF router ID is 2.2.2. That's my R2 router ID, process ID 1 and area 0. Then same LSA is there. Option field I'm not going to talk about right now. Okay, forget this guy. LSA type is router LSA. Link state ID is 101. Advertising router is 101. What is the sequence number of this person? What is the checksum? Length of this guy is the 60 bytes. How many links are connected to the R1? If you go to R1, just show IP OSPF database. Sorry. Is it 3 links, right? 3 links are connected to me, right? If you go to R2 router, right now, just take example router 2, right? This is the network engineer that is sitting on the R2 router. And let's see how I'm going to draw the topology. Let's see how I'm going to draw the topology. This is the network engineer. This is the Anup, and Anup is going to draw the topology based on the database table by sitting on a R2 router. So by looking at the database table, what he's saying that link state ID is 101. That's a router ID of 101, right? R1 is there. There's a one router R1. How many links are connected to this guy? 3 links. Okay. The first link is link connected to the stub network. Stub means loopback network. That is our 10.10.10.10.10. Let me create a one loopback network. Is it? Then link connected to the another stub network. That is 101. Okay, we have another loopback. That is both are stub network. Then third is link connected to the transit network. Okay, and in this transit network, what happened? What is the address of this guy? 1.1. Okay, this is my transit link. Right? And for this network, who is the DR? 106. So I don't know who is the 106. Just leave it right now. And this is my transit network. That's why I create the physical link over there. This is the physical link. That's why I created the physical link, because this is my transit network. Now, let's see the another one information. Now he's taking showing the information about the router 2, right? Link state router 2. So we have a router number 2 over there. That is a one stop network. And the ID of this guy is a 2.2.2. So let me draw the one stop network for this guy. Click /32. Then one is a transit network. Okay, let me draw the transit network that has IP address. Clear? And for also he's saying that the DR is, he was also saying the same information, right? Now let's come to the next point. Next he is talking about the link state array 3, right? So we have a R3 router as well as, okay, a link connected to the, I have a single link over there. Number of links is 1, and that link is going to say that transit network. Perfect. And transit network is router interface ID is 103. And what is the DR? Same information. Now let's look over the, do we have any links other? No, because he's saying a number of links is 1, right? Another LSA, that is R4. Okay, we have R4 router more. Again, this guy has a single link, and link connected to the transit network that has a IP address is 104. Okay, and he's also saying that same information that DR is 106. Now I have a single link, as we told you that, so we have a single transit network, we don't have any stuff. Next point, we have another router, that's a R5, and again this line has a single link, and this guy is a transit network, the DR is 106 and the router interface IP is 105. So let me draw the one link for the 105 as well as. Then after that we have another link, that is 6. Right, and this guy has IP address is 106, right? And this is the DR IP address. So this is the DR of this network. Any other information? No. So now your topology is something look like this. So Anup was just sitting on this router, right? Anup was sitting on this router, R2 router, and they have draw all the network. I told you that the map, what is the meaning of map? Google Map. If you just have a map in your phone of the, if you just have a map of the Bangalore in your hand, you can check it, right? Where I can go from where, right? You can check it, where is the Marathali, where is the Domur, where is the HSR layout, where is the BTM layout, where is the Kalyanagar, right? You can see that. Same thing. Just have a, I'm just present on the R2 router, and based on the R2, I can get all the information. I can draw my topology. This is the meaning of map. Guys, clear? Perfect. Now, one broadcast domain, one router LSA, right? Sorry, depend on the router, how many do we have router LSA. Next LSA we have a, this guy contain the information about link. Then we have our next LSA is network LSA. Network LSA is known as a type 2 LSA, and this information, this LSA contains the information about how many routers are attached. Network means what? Network is a subnet, right? This is the network 192.168.1.0. I'm using this network, right? In this network, how many routers are present? R1, R2, R3, R4, R5, R6. So network LSA, right? This network means what? This is the network LSA. Network LSA, that's the type 2 LSA, that's going to contains the information about how many routers are connected to me. And this information, this LSA will be generated by DR only. So who is the DR in this network, guys? Who is the DR in this network? R6. So R6 will generate a network LSA. only the DR is going to generate this LSA. If you go now any routers R2 right now, show IP host of database, we have a single router LSA. 1.6, the IP address link ID. Here the link ID is going to represent as a router ID, and here the link ID is going to represent the DR IP address. क्यों क्या हो गया? तो मैंने पहले ही बोला था बहुत ज्यादा कोरोना है यहाँ पे, मत आओ। मैं तुझे वही बोल रहा था, तो तू खुद ही लगा हुआ था फटाफट। देख ले तू, सुनना, मैं तुझे कॉल कर रहा हूँ थोड़ी देर, बैच ले रहा हूँ। So this is a DR, this link ID is the DR IP address in the network LSA. This link ID is the router ID in the router LSA. Who is advertising this LSA? 6, because R6 is the router ID of the DR. Same information, nothing is different. Of course, they don't have a link on because they are going to contain the router information. So if you want to see the detailed information of this guy, show IP host for database, network LSA. And now have a look over there. What I told you, that this network LSA is going to contain the information about what, how many routers are attached to me. How many routers are attached to me? So this guy is saying that I have a R6, and this is the IP of the DR. Is saying that I have a 6 router attached to me. Guys, till this point is clear, right?
Yep.
So in the one area, in the single area, you will only find the this two LSA. And this information will be never shared to the another area directly. Look like this manner, never share. I mean, say that if you see this information, right? This information I cannot see to the say to the different area, never. This whole information I cannot say to the different area. This is my area 0 information. This is the detailed information, right? A detailed information I cannot say to the different area. Area 1, area 0. I'm not going to say. Whatever the area 1 also have information, right? Area 1 means what? Group of router. Multiple routers are there, right? They will also never share the any information to the you. Own area has own information, that's it. Like this, right now, person is present in the Delhi and person is present in the Bangalore, right? This guy has a complete information on the Delhi, right? And this guy has a complete information on the Bangalore. They know each and every street. They know each and every street, right? But can Delhi guy know the each and every street of the Bangalore? Of course not. Bangalore guy also not know the in anything, does not know the street of the Delhi. Same thing, area 0, the detailed information I cannot say to you. Yeah, I will send you summary information, right? I will send you the summary information, short information, brief information, but not the detailed information. Detailed information is only about me, right? Whatever the routers that are sitting in your network, not networks, or in an area, right? They all have a detailed information. From anywhere, if you are sitting on a R1, R2, R3, R4, R5, R6, from anywhere you can draw your network. You can draw your topology. Understand? Now, 3 tasks to you, 2 tasks. Task 1, this router are sitting in the area number 1. This router are sitting in the area number 2. This is the task 1. Task 2, same area. Process ID 1 for this 12.0 network. Process ID 2 and process ID 3. Router OSPF 1 on this guy. Router OSPF 2 and router OSPF 3. Advertise this route, advertise this router, and loop back as well as, and provide the communication. Both basic tasks are tasks. इस weekend class है, Saturday Sunday both.
सर एडवांस की होगी क्लास?
अरे एडवांस weekend ही करेंगे, but not weekend this weekend. I think don't think so. From next weekend we can do that, because some persons are there in the weekend as well as, right? So they are saying that let's start from the next weekend because they have some task in this weekend. That's why it's saying that. So you can start from the next weekend. And one route batch will start from 11 a.m. morning Monday. So this is the physical batch. So if you want to join, you can join it. Physical batch.
Sir, sir, weekend, can you do in the evening, sir, or morning time?
8 p.m. morning, sorry, evening.
No, sir, weekend, what time will take OSPF class, sir?
Evening.
8 p.m.
8 p.m. is fine. 7 p.m. Tell me anything, because 10 to 1 I'm busy. Right. After that I'm totally free. So you
sir,
just
same time only you can take, sir, 5 o'clock like that. 2 hours.
Yeah. You can take that. Saturday, Sunday we can take that.
Okay, sir.
Okay, sir. Then 5:30.
Yeah, Saturday, Sunday we can, because we need to finish this also, right? So Saturday, Sunday we can do that.
Then it's the OSPF class or the route?
It's a OSPF class. Advanced will start from the next weekend, not this weekend, because some 5 persons are there in the weekend classes. They are saying that let's start from the next weekend. That's why I am stopping this thing.
Okay, sir.
And one route batch will be start from the 11th, from Monday, this Monday, that 11 a.m. morning physical batch will happen. Virtual also will happen, physical, both of them.
Tomorrow no class, no, sir?
Sorry?
tomorrow no class, no sir, OSPF.
tomorrow नहीं आता, कल तो मैं कि आज आज का रात वाला बैच कैंसिल करने का